Today we're going to talk about the conditional. So the conditional is another connective we have. We have the and and the or that we did before, and today we're going to add this conditional, and I thought we'd start by looking at this sign. It says you break it, you buy it. So what I think it really is trying to say to us is if you break it, then you must buy it. And this is an example of the conditional. So what we would say here is, well, let's call this statement, you break it, let's call that P, and then you buy it, let's call that Q, and we would write this in symbols as P with an arrow to Q. We read it as P implies Q, and I want you to notice the direction of the arrow. This shows the condition of the statement. It says when P happens, then Q will follow. So think about going to a store with this sign. We would all know the rules, and we would expect if we break something, then we would have to pay for it. And hopefully you can see this feels like true, I broke it, then true, I'm going to pay for it. So I can see T implies T is T. So true implies true is true. Well, what else could happen? Like these kids I had running through. Couldn't somebody kind of dash through a store and break something, leave without paying for it? That should feel kind of wrong, that, hey, we broke something, but then we didn't pay for it. That should be false. So true implies false. That shouldn't happen. The condition says whenever the first thing happens, the second thing has to follow. And here, the second thing didn't follow. So it makes it false. Luckily, most days we go into stores, we don't break anything. So we aren't obligated to buy anything. And when we do make a purchase, we aren't buying broken merchandise. So what these two statements here represent is, hey, we came into the store and nothing got broken. If we bought something awesome, we leave with something that wasn't broken, so that's absolutely okay to not break anything but buy something. It's also okay to not break anything and not buy anything. That's perfectly all right as well. So let's kind of summarize what happened there into a truth table. And I just want to generically put in my P and my Q, which we know P and Q. P is true, true, false, false. Q is true, false, true, false. When we put them together, here is what happens with the connective. I have true, true, true. True implies false, false. False implies true, true. False implies false, true. So big notice here. The only time the conditional is false is when true implies false. So I want to kind of point that out, highlight it more. I threw a star in there to say, pay attention to this. True implies false is false. Everything else is true. So let's spend some more time trying this and making sure we really understand the conditional. So let's go over another example I think you can follow. If your class average is over 90, then you get an A in the course. All right, so we're going to go case by case through and see what that looks like. So let's say, yay, it's the end of the semester and you have over a 90 for your average. You're going to get an A, and everybody's happy with that. True implies true is true. But let's check out this. What if your average is over 90 and I don't give you an A? That's bad, right? If you get over 90 and I don't give you an A, I know what happens. You call the boss, you call the president, you call everybody, right? You're really upset because this does not make sense. How can you have over 90 and not get an A? That's totally not okay. What about this statement? What if you don't have over 90 but I give you an A? You're not calling anybody now, are you? You're not going to complain that, hey, I didn't make a 90, but she gave me an A. You'd be like, best teacher ever, right? And maybe you're not going to call my dean, but you might give me a little like heads up on, right, my professor, go take Professor Barker. This part, false implies true, perfectly okay. The last statement, if you don't make over a 90 and I don't give you an A, you expect that, right? So if you end up with a 72 and I give you a C, you're like, yep, I got what I'm supposed to get. The only part here that was a problem where you like got, oh my goodness, what's going on, is when you got over a 90 but you didn't get an A, that's the problem. So true, false is false. That's what I want you to think about. All right, so let's look at this and stay with that idea of statements becoming symbols and then making a truth table. So let's check this out. You can't be a pilot in the Air Force if you are colorblind. Okay, so let's say this. Let's let P be you can be a pilot in the Air Force. You're going to notice every time we're going through these that when I'm putting together basic statements, I tend to leave off these words not. Those can be taken care of by that little squiggly tilde. You'll see it down here, that we can use. So I'm just going to say P, you can be a pilot in the Air Force, and Q, you are colorblind. All right. Here's what's really different about this one is look where the if is. Do you see the if right here? And let's kind of circle that actually. So here's my if. Okay. If should start the sentence. So whatever comes right after the if you are colorblind, that's going to be how my statement starts. So Q is you are colorblind. So here, you are colorblind. That's what's going to start me off. So Q implies not P. So this says, if you are colorblind, then you can't be a pilot in the Air Force. What's happening here is just how grammar works. We're allowed to flip things around when we talk, but the condition still comes this way. This is what stops you from being a pilot, right? Not being able to be a pilot doesn't mean that we're colorblind. There could be other things going on, like we don't have good vision, we're not the right height, right? But this says the colorblindness is what's preventing us from being a pilot. So it's really important when you order these sentences that you pay attention to how the conditional is constructed. Okay, so I would do this. I would circle the if and say, here's where my sentence begins. All right, so let's turn that into a truth table. So here's my Q implies not P, and I keep doing this to you over and over in videos where let's first look at the layout of the truth table before we try to fill it in. So I'm going to have P and Q. I need a negation of not P, and then the whole thing Q implies not P. So even though the statement starts with Q, I want you to use the same memorization we always use of how our P and Q structured. All right, so P is structured as true, true, false, false. Q is structured as true, false, true, false. So basic memorization we've done over and over. The negation of P just says flip it. So true, true, false, false is false, false, true, true. Okay, this order here, I'm going from Q to not P. So true, false is false. False, false is true. True, true is true. False, true is true. So the only time it's false is true, false is false. Everything else is true. Notice, whatever starts false, look, this was false. This is false. So I'm not doing a good job of circling for me today. So this false, anything false is immediately true. This was false, it's immediately true. Okay. So I want you to try this. I want you to convert the statement to symbols and construct a truth table. So the bank will be closed if it is a holiday. And just so your statement later looks like my statement in the truth table, I'm going to tell you I want P to be the bank will be closed, and I want Q to be it is a holiday. All right. Take a minute or two, pause the video, come back when you're done, and see how I did mine. Okay. So first off, here's my statement, Q implies P. Once again, I have this if. Right, there's a little bit better circling this time. All right, so if starts first, and that says holiday, and holiday I called Q, so this is going to be Q, and then implies P. So I have my true, true, false, false, true, false, normal for P and Q. But my statement is Q implies P, so when I'm reading, I'm going from Q to P, so pay attention in my truth table. I'm going true, true is true, false, true is true, true, false, there's my false, and then false, false is true. Okay, so let's do it again. Convert the statement to symbols and make a truth table. So if your payment is late or rejected, then your interest rate will increase. Okay, so let's call this first statement, your payment is late, let's call that P. Your payment is rejected, let's call that Q. Your interest rate will increase, let's call that R. Okay, so now I'm back to three statements. Notice my connective here is or, so these first two statements, P or Q, I'm going to put in parentheses, say do this first. After those two, see the then comes after, there's implies R. Okay, so once again, let's start with our structure. I have P, Q, and R. I need P or Q, and then I can do P or Q implies R. Okay, so let's start with here's what P looks like. When I've bumped it up to three statements, I need 4 trues and 4 falses. Q then will go in twos, true, true, false, false, true, true, false, false, and then R will switch every time. Okay, so let's start with P or Q, and notice these arrows that indicate I'm only looking at the first 2 columns. And again, let's talk about or. Or says I only need 1 true. So here I have true, 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 jump, true, true. there's 6 trues in a row. So 1, 2, 3, 4, 5, 6, and you can see 1, 2, 3, 4, 5, 6. The last two, false, 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 false is false. So here's my truth table just for that column. Then the last one, we're flipping over again. We're doing implies are. Pay attention. I'm doing this P or Q, and then I'm implying are. So I really want to read from the P or Q over to the are. So this is true, true is true. True, false is false. True, true is true. True, false is false. True, true is true. True, false is false. But then false, true is true, and false, false is true. So pay attention. I know this is tough at first. True implies false is false. You got to really get that ingrained in your head, and remember that's the rule for this conditional. Okay, so I want you to try the same kind of idea. Take these statements, make them into symbols, construct a truth table. So the statement I'm giving you is, if you have bad credit, then your interest rates on the loan will be higher and you will pay more fees for the loan. So I want you to let P be, you have bad credit. Q is, your interest rates on a loan will be higher. And R is, you will pay more fees for a loan. All right. Pause it, come up with your statement. You may want to check your statement first before you do the truth table. Make sure you got it right with the parentheses. Then fill in your truth table to see how that goes as well. Okay. So first, let's talk about, here's my statement. I have P implies, not Q and R. Let's go back and just look at this statement. See this if? Think of it cutting here at the then. So this is my first statement, P. Then the other two go together, and my connective was and. So this is why I have parentheses around the Q and the R, because they both are the then part. So you can see that here. Okay. My 3 basic columns I went ahead and threw in for you, the 4s, the 2s, and the 1s. Then we're going to take a look at Q and R. This time and, remember and says you have to have all true. So true, true is true. But here I have a false, makes it false. There's a false and a false, so those are false. Both true is true. There's a false, there's a false, there's a false, so those 3 are false. Okay. Now we're taking like this big stretch. First column over to the column we just finished doing. And we're reading in order from P to Q and R. So true, true is true. True implies false is false. True implies false is false. True implies false is false. Here's a little shortcut for you. See these 4? These 4 start with false. Anything false with the arrow is true. False implies true is true. False implies false is true. So having false as my beginning says shortcut and just go ahead and put true over there. Let's do it again. But this time I want to change it. Instead of doing truth tables, sorry, I couldn't find that word. Instead of truth tables, let's talk about truth values. So do you remember that when we know the truth value of a statement, we do not need to make a truth table? So here's an example. If 2 is even, then 7 is odd. Okay. We don't have to worry about, is 2 even or not? It is. 2 is even, that's true. 7 is odd, that's true. True implies true is true. So it's not this question of if you have bad credit or if the bank is closed, right? It's not that kind of thing, because it won't change. So some things do change. Some people have good credit, some people don't, right? So we have that option that can be different for different people. If you break it, if you get over a 90, see how those things had a choice, but 2 is even, has no choice. It's true. Same thing. If France is in Europe, then Canada is in Asia. Well, France is definitely in Europe. Canada is not in Asia. So true implies false. That's a false statement. Okay. Here, 2 plus 9 is 4. So if 2 plus 9 is 4, then 7 minus 2 is 6. 2 plus 9 is 4 is false. 7 minus 2 is 6 is also false. Here's where I say logic isn't always logical, because at the end we're going to say this statement is true. If 2 plus 9 is 4, then 7 minus 2 is 6 is a true statement. Try not to get too wrapped up into that. Follow the connectives, follow the rules, and just go, that's true. Right, one more. If the Statue of Liberty is in Florida, then the Eiffel Tower is in Paris. Okay, so the Statue of Liberty is not in Florida. That's false. The Eiffel Tower is in Paris. False implies true is true.